Hello, and we are back on page 78. Don't judge my 8, don't be a hater. So, Mr. Negron, the dork that he is, nothing wrong with being a dork, he's giving out paychecks in scientific notation, and we're talking about money, paychecks and money. So, look at these scientific notations here. Are they in scientific notation? Yes. Leading factor? Yes. Exponential power of 10? Yes. We're dealing with money, paychecks. These are relatively larger numbers. You can tell by the exponents being positive here, right? So what I'm going to do to organize my work is, since we're comparing numbers, I'm going to organize my work. I have 6.25 times 10 to the second power, and I'm comparing it. I'm going to put a inequality sign, remember from the beginning of the Nearpod. Right here, 6.30. I like to make it look like money, times 10 to the second power, excuse me. And so take a look here, just off of instinct, looking at these exponential expressions, which one do you think is the greater bonus check? Would it be this one? Would it be this scientific notation, right? Well, I noticed that $6.25, like not even looking at the power of 10, is less than $6.30. So right now it's looking like my hungry alligator would be pointing this way because this is greater, right? Even if you put this in your calculator, which you don't need to anymore because we just had a lesson on this, and you turn this into standard form, right? Times 10 to the power of 2, this is going to gain two place values. This is $625. And this is going to gain also, what do you notice is the same here? They have the same power of 10, right? So they're gaining the same number of place values, which makes it easy to compare even if we didn't do this work, right? They have the same power of 10 here, right? So we could just look at the leading factors and say, well, 6.3 is greater than 6.25, right? $6.30 is greater than $6.25. And we could do that because they had the same, the same power. So you could just look at the leading factor and tell the leading factor is going to show you which one is greater. Pause the video and look at example 5, though, because this is one of my favorite problems. This is actually pretty interesting. Pause, annotate the problem. Pause the video. I'm about to model it. Pause the video. See if you can do it on your own. Well, at least set it up on your own. Annotate on your own, okay? Mr. Charles has a check for 9.76 times 10 to the second power. Mr. Slivkin has a check for 1.3 times 10 to the third power. Which teacher got a bigger check, right? There's actually a really two ways you can do this, right? I'm going to show you the classic way, and then there's a spicy way you can sort of figure it out, right? So again, we're comparing numbers here, so I'm going to set my work up. Like a what? Like a bouse. Comparing it, leaving a space to compare. Right? And just to make sure we can read the 6.25 times 10 to the second power is less than L, 6.30 times 10 to the second power. Make sure you can read those inequalities. Now here, what do you notice is different here, right? They're both in scientific notation. What is different here that's different from our example 4? That's right. They have different powers of 10. So do you think we could just look at the the leading factors and think, yeah, well, we could tell 9 is greater, right? So it should be 9. We can't just look at the leading factors now because they have different place values, different powers of 10. So what can you do? What are you going to do? Well, this has a greater power of 10. This has a greater place value here, right? So off instinct, a lot of people think, oh, 9 is greater, so this is greater. But you got to look at the powers of 10, right? You got to look at the powers of 10. For instance, if I gave you 9 times 10 to the second power compared to 3, right, times 10 to the 10th power, just because 9 is greater don't mean that this is going to be the greater value. Immediately you can see, oh, you're getting 10 place values over here. This is greater. Same thing over here. Because you have a greater power of 10, you know this scientific notation expression, this exponential scientific notation expression, is going to be greater. You have a greater power of 10 here. Don't believe me? Well, let's check it out. All right. So if we turn this into standard form, it's gaining two place values. What is that? $976. And how about this one on y'all? What about this one over here? Right? This is gaining 1, 2, 3 place values. So I'm going to add 2 zeros in those empty spaces. Look at this. We were right in the end. And how could we tell immediately by looking? We didn't even need standard form. Is the powers of 10, if it's greater, obviously it's going to be a greater value, right? But if the power of 10 are the same, then you look at the what? Then you look at the leading factors. Now, very quick, if you understand that part, go to the next slide. You can do example 6 on your own, fill in the vocabulary, boom, you're done. If you want to get spicy with it now, because that's what Mr. Lyons is about, we about getting spicy with it. Let me show you something that's going to come up in a couple lessons. But if you with me, then you with me. You could kind of understand. What could I do to make the powers of 10 the same so that I can just look at the leading factors and compare? How could I make this power of 10 equal to the same power of 10 over here, right? Well, what I want to do is I'd want to increase my power of 10 right here to 3, right? I'd want to turn this into 10 to the third power. But remember on the previous page, where am I getting this place value from? I can't just turn it into 10 to the third power and keep my same leading factor. What would I have to change about my leading factor here? That's right. I would have to, since I'm gaining and my exponent is gaining, it's getting larger here, I have to take away a place value right here. So this is going to be 0 point, right? 976. Compare that to 1.3 times 10 to the third power. Even here, now that we have the same powers of 10, we could just look at the leading factor. This is still going to be less than 1.3 times 10 to the third power, right? This is the spicy version, though. We're going to get to this in a little bit. But if you could understand what I'm doing here, you're doing fine, right? This is from the previous page. But here as well, you can just tell by looking at the powers of 10 which one is greater. If they have the same power of 10, you just look at the leading factor, right? Spicy over here, right? So this is going to be greater. This one's going to be greater, right? What you're going to do now is you're going to check out example 6. You're going to do example 6 on your own, right? List the following numbers in order from least to the greatest. Use inequality symbols, right? So you're going to, what I would do for you is I would just put inequality symbols here, here, and here, and then you're going to fill in the, you're going to put in scientific notation out from least to greatest. I would do least, 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 and then the greatest would be over here, right? Just setting that up for you, okay? Going to do that on your own. Going to figure out the vocabulary. Thank you for watching. Thank you for listening. We compared numbers in scientific notation today. We traded place values on the previous page. Don't you ever forget it, right? I'll say it again. Thank you for watching. Thank you for listening. Remember, the future belongs to those who prepare for it today, and I'll check you later.